How do you eliminate in systems of equations? I'm Jesse Brockwell from Capstone Academics, and my highest purpose is to make math easier for you and to make it enjoyable in the process. So let's get into it. You'll want to use elimination if both equations are in the form ax plus by equals c, or if trying to isolate one of the variables is going to get you a fraction, which is just going to be a whole mess. No one likes a fraction fest, right? So here we go. First one I want to take us through is 5x plus 2y equals 10, 7x plus 3y equals 11, because this particular problem will force you to eliminate in such a way that will illustrate how you do all elimination problems in general. And that is primarily to start by looking at the x's and the y's and deciding which of those variables is easier to have the variables meet up at. So you want to think about these like common denominators. So like 5 and 7, where would 5 and 7 meet up for a common denominator? Well, they meet up at 35, okay, if you're familiar with common denominators and all that kind of stuff. But in case you're sort of having a brain fart, common denominators kind of work like this. Like if you were to count up by 5s, 5, 10, 15, 20, 25, 30, 35, right? And then count up by 7s, 7, 14, 21, 28, 35. Oh, look, we've got a number that they both meet up at. This is where we want to bring the x's to, okay, if these are the ones that we're going to eliminate. But if you look at the y's, that's going to be way easier. So if you count up by 2s, you've got 2, 4, 6, 8, 10, blah, 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 3, 6, 9, 12. And if you look how early these meet up, it's going to be way easier to cancel the y's. So let's go ahead and do that. Now I'm just going to erase this. So this too. Yes, come now. Okay, so what do we need to multiply the top equation by to get that 2y up to a 6y? It'll just be 3, right? So multiply both sides by 3. Make sure you hit that 10. A lot of people forget to do that. Now, the bottom one, what do you need to multiply this 3 by to get up to a 6? Well, it needs to be 2. But you'll want one of them to end up being positive 6y and the other one to be negative 6y. That way, when you that way when you add the two equations, the y's will actually cancel each other out. Now, some teachers teach you to subtract the equations, okay, but I find that that creates way too much juggling in terms of like mental negatives. It's way too prone to silly mistakes, so you might as well just have one of them turned out to be positive 6y, the other one negative 6y, and just add them so you don't have to do any mental juggling of signs. That's my 2 cents, right? So multiply the bottom by negative 2, make sure you hit all of these numbers. I'm gonna go ahead and write the results down here. So we've got 15x plus 6y equals 30. Bottom is negative 14x, negative 6y, negative 22. And you'll go ahead and add those. 15x minus 14x is 1x. Those 6y's are gone. And then 30 minus 22 is 8. We've got our first variable. Now that we have this, let's take the x and plug it back into the easier of the two equations. You can actually plug them into either one. It could go here, or it could go here. But which one is easier? Probably the top one, because the 5 has a lower multiplier, so it's just like lower numbers in general, right? So let's go ahead and plug it into the top. It'll look like this. 5 times 8 plus 2y equals 10. 40 plus 2y equals 10. Subtract the 40. 2y equals negative 30. Divide by 2. Y equals negative 15. Now, if you write that as a point, it'll look like this. xy, I'll just go ahead and write that in the order here. xy is 8, negative 15. Now, the reason why it comes up as a point is because if you graph these two, I'm not saying this is how this graph looks, but like, let's say one of them looks like this and the other one looks like this. 8, negative 15, right here. Ignore the scale, guys, or else you'll like unsubscribe immediately. So 8 to negative 15 looks like that. It's the intersection point of the two lines, and therefore the solution of the system. Now, by the way, guys, I've designed each and every one of these problems to illustrate a different subtype of elimination. That way, you'll be prepared for whatever you might see on the actual test or on the quiz or whatever you're dealing with homework. But yeah, all of these different subtypes are the most common that you will see. So if you can do these pretty well, then you're prepared. Okay, this one is actually pretty straightforward because we've already got the y set up to eliminate. Now that's just gonna happen sometimes. Like sometimes you can just add these right away. So if you add the x's down, it's like 2x, and oh look, the y's cancel, fantastic. So 8 plus 2 is 10, divide both sides by 2, and x is 5. too easy. Now, remember, take this, plug it into the easier of the two equations for you, right? So probably the top one to avoid negatives if you want, although I would suggest getting familiar with those. So 5 plus y equals 8. Subtract 5 from both sides. Y is 3. Solution again as a point. 5, whoa, 3. There we go. Next up, we have x plus 3y equals 10, x plus 4y equals 12. If you look at the x's, and if you look at the y's, which one's easier to have cancel? Probably the x's. Like, yes, these would meet up at 12, which is not so bad, the 3 and the 4, right? But if you just multiply the bottom one, or the top, by -1, then the x's are going to cancel right away. So I'm just going to rewrite the top here. X plus 3y equals 10, and now that I'm distributing the negative to the bottom, -x, -4y, -12. Now you can just add these downwards, so x minus x, 0, it's gone. -1y, or just -y. 10 minus 12, -2. Divide both sides by -1. That negative is a hidden -1. And then y is +2. Where's the easier of the two to plug back into? Probably the one with the lower multiplier, so we're going to go right there. So we've got x plus 3 times 2 equals 10. X plus 6 equals 10. Subtract the 6 out. X is 4. And then we've got 2, 4 as the result. There we are. So, this little guy. Okay, sometimes you only need to multiply one of the equations by something to get it to cancel. So, in this case, if you look at the x's, so these would meet up at 4. Like, yeah, they meet up at 8 and stuff, but the sooner place that they meet up is 4 versus the 3 and the 5, which would meet up at 15. So having the 4 and the 2 meet up at 4, you could just multiply this guy by -2. Leave the top one just the way it is, and then -4x, -10y, +8. Go ahead and add those together. The x's are gone. -7y equals 14. Divide both sides by -7. Oh my god, it's like these are worked out beforehand to make magically nice numbers. Happy accident, maybe. So, plugging into the top right here, easier with a lower multiplier, right? I'm beating a dead horse, guys, but you know. So, 4x minus 6 equals 6. Add this 6 over. 4x equals 12. Divide both sides by 4. X is 3. 3, -2. There we go. If you guys are finding this helpful, please go ahead and smack the like button below and subscribe for more math help all year long. Thank you, thank you. Guys, do be sure to hang in till the end because I got a pro tip for you and a 2-problem test that you can take to see if you're cleared and ready to go. If you can pass this 2-problem test, then you should be all set for whatever you're going to see, with the exception of nasty decimal and fraction problems, which your teacher may give you if they haven't gotten over early childhood traumas. For now, though, the weirder situations, like no solution and infinite solutions, we gotta talk about those. Okay, let's see what happens here. Are we gonna cancel the x's or the y's? So 10 and 4 are gonna meet up at 20 is the soonest number, right? Versus 5 and 2, which is 10. So let's go ahead and have the y's meet up at 10, lower numbers, right? I'm gonna multiply this one by +2 to get this to a +10y, and I'll multiply the bottom one by -5 to have this one come up to -10y. So I'm gonna distribute this real quick, and then also this, and 20x plus 10y equals 30, and then we've got -20x, -10y, -25. I see trouble. Uh-oh. X's are gone, y's are gone, 0 equals 5. Is this true? No. No. The x's and y's are both gone, which means regardless of what x and y could possibly be, this will never be true. This is false. So, this is a no solution situation, okay? So, when both sets of variables cancel and you end up with a false statement, that's what produces no solution. Now let's get on to infinite solutions. The infinite solution situation looks really, really similar, as you're gonna see. So, should we have the x's meet up at 6 or the y's meet up at 12 and cancel? Well, probably the x's, because they meet up at 6, it's lower, right? So we're gonna multiply this top one by 3 to get to +6 for the x, and then this one by -2. So let's distribute that 3, and then distribute the 2, and then results here. So 6x minus 12y equals 18. and then negative 6x, positive 12y, negative 18. You guys see what's going to happen? X's are gone, and you have 0 technically on the left side, right? When everything disappears, and then 18 minus 18 is 0. Is this true? Yes, it is. So, regardless of what x and y are, the equation always makes sense. So it doesn't even matter what x and y are. So we have infinite solutions. That's the whole idea here. So for no solution and infinite solution situations, both sets of variables are going to cancel, but if you get a false statement, like we did before with a no solution, that's going to be no solution, right? And if it's true, like 0 equals 0, then it's going to be infinite solutions, because these are technically the same line, overlapping one another, right? So we have an infinite number of intersection points. That's what this looks like graphically, versus the no solution situation over here, which is where the two lines are parallel. So they never intersect, no matter what x and y are. So, by the way, for your notes, I'll go ahead and write infinite solutions up here. Beautiful. Take a screenshot. It'll last longer. Pro tip, guys, for all of you who finally made it to the end, here we go. If you notice that you can divide all of the terms in the equation by some number to sort of reduce it down, you can do exactly that. So like, oh, look at the 8, the 12, and the 16. All those are divisible by 4. You might as well divide them by 4. It's good for your health, right? Looking at the 9 and the 6 and the 12, you could divide all those by 3. Let's do that, right? So I'm just going to sort of write this out to give me some more space and fix my horrible handwriting. And then, but you guys are still here, thank you. So here we go. I'm going to divide all of those by 4. Well, here, let me fix that. Divide this by 4 and this by 4, and let's see what we get from that. We got negative 2x, positive 3y, and then equals 4. That looks a lot healthier than what we had before. Divide all this by 3. Negative 3y, positive 2x, negative 4. So that's what we got there. Should do a little parallel structure here, Jess. Come on now. So we've got negative 3y, positive 2x equals negative 4. Okay. Now, what do you notice about these? These are in the wrong order. Okay, so let's switch these around and we'll have our final form of this. 2x minus 3y equals negative 4. So there we go. And then, oh, look at this. That looks suspicious, doesn't it? So if we stack these up, negative 2x plus 3y equals 4. And then we go to add these. It looks like the x's are going to cancel. Oh, it looks like the y's are going to cancel too. Oh, and the 4. 0 equals 0, which is true. So, infinite solutions. Remember, if it's true, infinite solutions. Nice job. Last one, guys, here we go. Let's do it. So if you look at this, this is all jumbled and out of order. Let's fix this. We want them to eventually look like this, like ax plus by equals c, ax plus by equals c. So let's sort of make it happen. What's the easiest way to manipulate the top one to get this shape? I would say adding that 6x over will be the best plan. So I'm just going to sort of copy this down, give some space, add the 6x over, and then rewrite with the 6x plus 5y equals 4. This one's good to go. And then how about this one over here? I would say what we should do is just add that 4y over, and we should be all set. So let's add the 4y. Boom, boom. 7x plus 4y equals 12. So this one's all good too. Now we can sort of take on that process of like, where's the easiest place to have these meet up? So if we look at the 6x and the 7x, those are going to meet up at 42. Spoiler alert, like terrible, not cool, right? So we might as well have the 5 and the 4 meet up at 20. So multiply this one by positive 4, this one by negative 5. Let's go ahead and write the results. 24x plus 20y equals 16. And then on the bottom, negative, well, I'm going to write it right here. I'm going to go right there. Negative 35x, negative 20y, negative 60. Oh boy, it's going to test my mental math. You guys are going to unsubscribe right now. Negative 11x equals negative, oh my god, 44. That was close. Negative 11. And then x is positive 4. Where's the easier place to plug this in? Probably the one with the lower multiplier right there. So off to the side here now. 6 times 4 plus 5y equals 4. 24 plus 5y equals 4. Subtract the 24 out. 5y equals negative 20. And then divide by 5. And y is finally negative 4. So, in purple for the final answer, 4, negative 4. Great job, guys, if you were able to get through that on your own. Well done. Elimination, again, not super terrible, right? The concept is look at the x's and the y's, which is easier to meet up in terms of a common denominator. Go ahead and cancel them, see how it turns out. If both sets of variables cancel, if it's false, what you get, like 2 equals 12 or something, once the x's and y's are gone, no solution. And if it's true, like 0 equals 0, infinite solutions. If you guys learned something out of this video, please do hit the like button and subscribe for more math help videos all year long. I'll be churning out 1 or 2 videos every week. For those of you interested in more in-depth walkthroughs or one-on-one tutoring and test prep, head over to our website at capstoneacademics.com. Reach out through our contact us form, email us, or call us. The link's in the description below. Also be sure to check out our full-length SAT walkthrough videos that pick apart every single little aspect of every problem on a given test from the College Board SAT official guide. They are extremely helpful, essential videos. I highly, highly recommend them. This is Jesse Brockwell from Capstone Academics. Thanks so much for watching, and see you next time.